Hello Red Seal friends, how are you again? In this video I'm going to do a calculation of the power supply wiring as well as the calculation of individual loads. That will be the basis for the sizing of the power supply wiring. Okay, so yeah, welcome to another refrigeration HVAC red cell practice questions once again. And I only have one sample problem. This is also based out of the sample problem that's given on the redseal.ca sample problems that they have on their website. Okay, so calculate the total amperage capacity and select the wire size of the power supply wiring for a walk-in cooler which has 208 volts voltage power supply and the following loads. So this walk-in cooler has 208 volts power supply, and these are the loads. It's got four types of loads. Number one is 4 evaporator fan motors rated at 9 watts each. It's got 2 defrost heaters rated at 6 amperes each, 6 fluorescent lights at 40 watts each, and 1 strip mullion heater rated at 3 amperes. This strip mullion is to prevent condensation on the doors of the walk-in cooler. Okay, so typical loads of a walk-in cooler. So we analyzed the given. We got 208 volts power supply and the loads above, which are these four things here: evaporator fans, 4 of them, defrost heaters, 2, fluorescent lights, 6, and 1 strip mullion heater. The unknown, we got 2 unknowns. We need to calculate the total amperage capacity of the supply wiring and to size the wire that can safely carry our total loads. Okay, so the solution, we will use this formula here. Power is equal to I times E, I being the current and E is the voltage. So we just rearrange the formula. The formula for I in amperes is equal to power divided by E, which is the voltage, which is 208 volts as given. Okay, so the first step is we need to calculate for the individual loads, starting with the 4 evaporator fan motors that are rated at 9 watts each. So very simple. Power is equal to 4 times 9, so 4 evaporator fan motors times 9 watts each is equal to 36 watts. And then so we got 36 watts for power, but then we need to calculate the amperage for this for evaporator fan motors. So we just divide 36 watts divided by 208 volts of power supply, so we get 0.17 amperes. The next load is the 2 defrost heaters rated at 6 amperes. So we just simply 2 times 6 is equal to 12 amperes for those two defrost heaters. The next load is 6 fluorescent lights that are providing light inside the walk-in cooler, so that when you go in and go in, so that when you go inside the walk-in cooler, you have a lighting. So that's the purpose of the 6 fluorescent lights. So we got 6 of these fluorescent lights times 40 watts each. So we got a total power consumption of 240 watts. We use the same formula as before. I is equal to P divided by E. So we have 240 watts divided by 208 volts, and we got 1.15 amperes. And last load is the strip mullion heater to prevent condensation. We got 3 amps. So 1 times 3 equals 3 amps. So then the total amperage, we just add the 4 individual loads that we calculated. The amperage for those loads is equal to 0.17 plus 12 plus 1.15 plus 3 is equal to 16.32 amps in total. So that's the answer to question number 1. And the second question is to size the power supply wire that can safely carry the above loads. So for good practice, we add a safety factor for overload. In this case, I'll be using 20% as the safety factor. Of course, some designers, they add 30, 25, or even 50, but in this case I'm just using 20% as the safety factor. So I is equal to 16.32. This is the load that we calculated above there. So we got 16.32 times 1.2 for the 20% factor. So we have I is equal to 19.6 amps. This is amps. And so we need to select 20 amperes wire size so that it can safely carry the 19.6 amperes for the load of the walk-in cooler. Okay, I hope you have learned something from this. For any questions, please don't hesitate to leave me in the comments, and I'll see you again in the next video. Okay, cheers, have a good one, happy reviewing, wish you all the best for your Red Seal exam. Cheers, have a good one.